Next, we're going to look at other reactions of carboxylic acid derivatives, including other nucleophilic acyl substitution that's not just the interconversion between the derivatives, but other types of reactions. In this video, we're going to talk about carboxylic acids themselves, as well as acid halides and anhydrides. Now let's try to pull together everything we've seen in terms of carboxylic acids. So first of all, with preparation, we know that if we have a primary alcohol, we can oxidize this with potassium or sodium dichromate, sulfuric acid, and that will give us a carboxylic acid. We also know that we can oxidize an aldehyde using the same conditions to give us the carboxylic acid. If we have a Grignard reagent, this can be treated with carbon dioxide followed by aqueous acid workup to give us the acid where this piece came from the Grignard and this came from the carbon dioxide. And another thing that we've seen is that we can take a nitrile and we can hydrolyze it. So, for example, HCl and water, this would be a stronger, more concentrated acid than just aqueous acid workup. And this is going to hydrolyze the nitrile to give the carboxylic acid. So we've seen a number of ways to make carboxylic acids. Let's review what we've seen in terms of reactions of carboxylic acids. So one thing we've seen is that this can be treated with lithium aluminum hydride followed by water, and the carboxylic acid can be reduced to a primary alcohol. We can take our carboxylic acid and treat it with an alcohol in the presence of H+. This is a Fischer esterification, and that will give us an ester. Another way we can make an ester is by making the acid into our nucleophile. So we could treat this with base in order to pull off the proton, and then we add some Rx, and this will have to be methyl or primary alkyl halide so that we get SN2 reaction, not elimination. But this will give us also an ester. And then one other reaction that I just want to mention, carboxylic acids can be treated with amines in the presence of a coupling reagent such as dicyclohexyl carbodiimide, and this will give an amide. And this one was made very popular in terms of peptide synthesis. So when folks are trying to make small proteins, for example, then the DCC coupling is very, very common. You're not responsible for this. I just wanted to mention it. But these others, both in terms of the preparation of carboxylic acids and some of the reactions of carboxylic acids, I want you to be familiar. Oh, and another thing that I already forgot. The acid can be treated with thionyl chloride to make an acid chloride, or it can be treated with phosphorus tribromide to make an acid bromide. And I think this gives us a complete look at preparation and reactions of carboxylic acids that we have discussed so far. Now let's do the same thing with acid chlorides, or more generally acid halides. So we can prepare them from a carboxylic acid, treating this with thionyl chloride, or we could take a carboxylic acid, treat it with PBr3, and that would give us the acid bromide. Now, an acid chloride or an acid bromide will undergo the same reaction, so I'm just going to lump those together, and let's think about what we've seen. Early this semester, we saw that if we have benzene, for example, and aluminum trichloride with an acid chloride, this will give us a Friedel-Crafts acylation. In this chapter, we saw that we can do nucleophilic acyl substitution. So if we take this acid chloride or acid bromide and react it with a carboxylic acid, we can make an anhydride. We can react these with an alcohol to form an ester. We can react these with an amine to give an amide. These can be hydrolyzed to give a carboxylic acid. That's not synthetically useful since we just made this from a carboxylic acid. These are the different nucleophilic acyl substitution reactions to interconvert carboxylic acid derivatives, and we have hydrolysis to the carboxylic acid. But we still have a few other reactions. So acid chlorides can be reduced. So lithium aluminum hydride followed by water, and that would give us an alcohol. This is not really useful because once again we could have just reduced our acid rather than going through an extra step. These can be treated with a Grignard. Step 1 and then step 2, aqueous acid workup, and this will give us an alcohol where 2 equivalents of Grignard have added. So this is similar to what we saw with esters, where first of all 1 equivalent of Grignard will do nucleophilic acyl substitution, and then a second equivalent will do nucleophilic addition. One more example, rather than a Grignard or an organolithium, if this is treated with a cuprate. So in this case, it will do nucleophilic acyl substitution and then it stops. It does not undergo a second addition, a nucleophilic addition. So with an acid chloride, you can use a Grignard to add 2 equivalents to end up with an alcohol, or you can add a cuprate where just 1 equivalent will add to give you the ketone, and then it does not undergo a second addition. So we have just a couple of ways to make acid chlorides or acid bromides, but we have a lot of reactions that these can undergo. Next, let's consider anhydrides. So these can be made from acid chlorides or acid bromides by treatment with a carboxylic acid. That's the only way that we're going to focus on for preparing anhydrides. Now, what reactions can they undergo? This can be treated with an alcohol, and that will give us an ester. But keep in mind, you either need this to be symmetric or else you run the risk of the alcohol could add here, giving this product, or the alcohol could add here, giving this product. So the same thing would be true for all of these. The anhydride could be treated with an amine to form an amide. It can be hydrolyzed to give an acid. It can be reduced to give an alcohol. But for the most part, think about the anhydride. You have this part of the molecule ends up in your product, and this whole part of the molecule just gets well, washed away. So there's a lot lost when it comes to an anhydride. So think of this as a really big leaving group, which makes this kind of wasteful. So on paper, at least, using acid chlorides is probably better than using anhydrides. In our next video, we're going to continue with this overall look at preparation and reactions of carboxylic acid derivatives, continuing with esters and amides.